Station, this is Houston. Are you ready for the event?
Station, I am ready for the event.
Sky News London, this is Mission Control Houston. Please call station for a voice check.
Playing games. But perhaps it is the view that he'll remember.
Hello, this is Sky News Sound calling for a voice check.
Well, there we can see Tim Peake on the big Sky News wall.
And Sky News Sound, this is Tim Peake on the International Space Station, loud and clear.
Station, this is Sky News London. How do you hear me?
Hello, Sky News in London, and hello to everybody at the National Space Centre, Leicester. I hear you loud and clear.
Ah. Fantastic, Tim. It's great to join you. Thank you so much for joining us. Thanks for giving Sky News your first live broadcast interview. We're absolutely delighted to speak to you. We've got a load of people here in the studio. We've got our science correspondent, Thomas Moore. We've also got 3 space engineering students. But our first question, and I'm sure you'll be thrilled, given part of the aim of your mission is to engage children, is from some children. It's from Neve, who's 7, and Matthew, who's 9. And they would like to know, what moment would you describe as being out of this world since you've been in space? You're just showing off with that microphone, aren't you?
Hi, yeah, that are great questions. What's out of this world? You know, the whole experience has been out of this world from the moment I first saw planet Earth from my Soyuz window just after we'd been inserted into orbit. But I have to say, every time I go to the cupola and look out, that's the most out of this world moment. It's always different, whether it's a moon setting or a sunrise or crossing over and over the South America, for example. The magnificent views, that's definitely out of this world.
The views of the Earth from space. Thomas Moore has got another question for you. Thomas.
Tim, it's another question from the audience. Being British, we're obsessed with the weather. So this question is from Peter Stewart Hunt. I know it doesn't rain in space, but do you get changeable weather? You do get space weather, don't you, Tim?
Well, that's a very good question. Yeah, we do get space weather. We pass through space weather. For example, the aurora, which can be extremely beautiful and amazingly bright at times. Actually, inside the space station, we maintain a pretty constant atmosphere. It's about the same pressure as Earth atmosphere and about 21 degrees Celsius and a fairly steady humidity as well.
Tim, it's Jane again. You knew what you were getting into. You talked to all the astronauts. You did a lot of preparation. You knew what you were going to miss, the kind of things we'd all miss, our family, our friends, the routine. But is there anything up there that you've missed that you weren't expecting to miss?
Do you know, that's something that I've thought about recently, and it is the fresh air, of course, and being outdoors, but it's also the color green. And it was Scott Kelly who prompted me to think about that, because as soon as he got down to planet Earth, after his 1-year stay aboard the space station, he posted a lovely photograph with lots of green in it and said, we don't have the color green on the space station. And that's very true. So definitely the fresh air, outdoors, and the color green are things I'm looking forward to seeing again.
And given that it's the greenery, it's the fresh air and space that you're missing, what do you think has been harder? Has it been the physical challenges or the mental challenges? What have you found harder to cope with?
Do you know, our training is so good that it really prepares you for everything that you might encounter on board the space station. And myself and my Soyuz crew, we've just passed our 100 days in space mark. And there have certainly been some mentally and physically challenging events during that time. The spacewalk certainly was one of those. This weekend, we also captured the Cygnus cargo vehicle, which is, again, another demanding task for astronauts to do. But we're so well trained for these events that actually we just take them all in our stride and we let the training take over and they run to plan.
Okay, Tim, we've got a question from space student Richard in the studio now. Richard, take it away.
Hello, Tim. I'm Richard. And here's my question. You've been training for this mission for 6 years. how did the reality of microgravity differ from your training experiences, and did anything surprise you?
Hello, Richard. That's a great question. And of course, it's very hard to give us microgravity training on planet Earth. The way they do that is by letting us experience it for short periods of a time on parabolic flights. But you only get about 30 seconds each parabola. And so that's not much zero gravity time. So really, everything that I've had to learn about living and working in microgravity has been on-the-job training. And it's certainly a lot of fun. It can be very frustrating at times. I've certainly lost a few things. Thankfully, most of them I've found again. But it's very easy to put things down and to turn around, and then they're not there again. Everything floats away. So you'll see Velcro is everywhere on the space station to try and keep control of things. But after a couple of weeks up here, you really do get used to living and working in microgravity, and your brain also gets used to it as well. You know, I can work in any orientation I like, really, and it doesn't matter whether I talk to you upside down or the right way up. My brain just kind of flicks the picture.
Richard, great question. I'm just looking at your face glowing as he answered that. You're thrilled to have had this chance to ask, how aren't you? Let's get another question from Leicester this time. This is from Lily. This is the one from Lily in Leicester, Tim.
Hi, I'm Lily and I'm 16. What would you do in case of an emergency? So if there was a fire.
Lily, that's a great question, and we train an awful lot for emergencies on board the space station. You mentioned a fire there. Of course, that would be a very dangerous situation. Also, if a piece of debris were to strike the space station, we could suffer a depressurization. And also, there's a risk of an ammonia getting into our atmosphere. So they're the three big emergencies that we train for. And we would fight the fire by firstly trying to remove any electrical power. That's normally the source of any ignition. And then we've got fire extinguishers and portable breathing apparatus we could wear up here and put the fire out. And we've got lots of equipment that could then scrub and clean the atmosphere to get the space station back into a working configuration. And if we really had to, if it was a very serious situation, of course, we've got our Soyuz spacecraft docked to the space station. Then that's our lifeboat for the 6 months we're up here. We would evacuate the space station back down to planet Earth.
Tim, you spend a lot of your time in the Columbus module there, the European Space Agency's laboratory. Just explain to us the kind of experiments you're doing up there when we don't see you performing in front of camera like this.
Yes, we're working, 12, 14-hour days, Monday through Friday, and also at the weekends as well. And we're doing so much scientific activity. We're also maintaining the space station, of course, keeping it operating. And for example, this morning I was working in a Japanese laboratory all morning, preparing for a payload that's going to go outside the space station. So we're not just doing research inside the space station in a microgravity environment, but we're also using the vacuum of space, the temperature fluctuations of space, investigating all sorts of things, such as, what microorganisms might be able to survive in space. And we're doing plenty of other scientific research in areas such as fluid physics and medical research.
Now, Tim, we also have a question from one of our students in the studio. This is David.
Hello, Tim. My name's David, and my question is that as part of your mission, you're doing a lot of experiments up there with ESA and with schools. Which of these experiments do you think will have the greatest impact down on Earth, and which had the most unexpected result?
Hello, David. Another great question. Gosh, we're doing about 250, just over 250 experiments during my 6-month mission. So that's really hard to say which one will have the greatest impact. I mean, for example, we're investigating metal alloys up here and how to make lighter, stronger metal alloys, which could have huge impacts to, for example, our aviation industry and into how we manufacture components for aircraft. We're also investigating plenty of medical research as well. I think that will probably potentially have the biggest impact back on Earth. For example, we're looking into drugs and how protein crystals can be grown in microgravity, which enable us to manufacture much better drugs that are much more effective with less with less side effects as well back down on planet Earth. And of course, we're investigating our own human bodies as well up here, looking into things such as the aging process in terms of our muscle atrophy and our bone density loss as well, in terms of our eyesight and our increased intracranial pressure as well, and our cardiovascular system, not to mention our immune system, which gets depleted up here, and also questions such as why a virus is more virulent in microgravity and how we can use that to develop vaccines back on Earth. So I think personally the medical experiments are some of the most exciting and interesting ones that have the potential to benefit people back on planet Earth the most.
Now, Tim, you've also been doing some demonstrations for science students, and one of those science students is Emily. Now, you've got some kit there that you actually designed for Tim, really to just show how difficult it is to demonstrate physics here on Earth. And it's a track and a ball. Just show us what actually happens there. And gravity is really just pulling that ball back down. Now, Tim has actually done the same experiment. You weren't able to do it live, but we got the video of you demonstrating what happens when you're in microgravity with exactly the same kit. We don't seem to have a video, unfortunately, but the ball the ball does continue all the way around. Just explain, Tim, what's happening.
Yes, again, it's one of the phenomena of microgravity. It's a wonderful environment to demonstrate some of those basic scientific principles. And it was a great opportunity to be able to do some videos of this kind of thing that can be used by school teachers in classrooms all around the UK and across Europe to try and demonstrate some of the physics that are involved. And for example, the kinetic theory of gases, we can demonstrate that really well up here with a clear ball and lots of marbles inside. And the particular ball going around the tube is just you can demonstrate concepts such as angular momentum and conservation of angular momentum. So I spent a great afternoon doing some fun videos that will hopefully be seen in schools for several years to come.
And a question, Tim, from the National Space Centre in Leicester again. This is Kevin. He's 9.
9. My question is, how many galaxies do you think there is?
Hello, Kevin. Goodness me, what a wonderful question. When I look outside the cupola at night time, even to try and count them all would be a task that will be way too difficult. But the best scientists and astronomers have estimated that there might be at least 100 billion galaxies in the universe, each one containing 100 billion stars, which is just mind-boggling, that kind of figure. There's a fact out there that there are more stars in the universe than there are grains of sand on planet Earth, which seems too mind-boggling to even comprehend. But being up here and looking outside the cupola at night time, I can really believe it.
Fantastic. Thanks for that. I don't know if you know that Kevin, I don't know if Kevin was more stunned that you were answering his question or that he was on the big screen at the Science Centre. He was absolutely thrilled to get that response. A couple of tougher questions for you, though, Tim. You're obviously having a fantastic time watching you playing with the microphone. You're answering tweets from children all the time, but the cost of this mission, it is billions. Do you really think it's worth it?
That's a very good question, and I absolutely do think it's worth it. I mean, not forgetting that up here, of course, it's not just one country that's involved in this. This is multiple countries across the world. It's a huge international collaboration between the US, between Russia, Canada, Japan, and all the member states of Europe as well. And we've been doing research up here since the year 2000, when the International Space Station was first occupied. It now has a life extension till 2024. So that's a fantastic working laboratory doing great research. And of course, money that's spent in space is not spent in space, it's spent back on Earth. It's jobs for the economy, it's pushing the space industry to its limits. The space industry in the UK alone is one of the fastest growing sectors. So it's worth it for so many different reasons.
We've got another question from a viewer now. This one is from Jonathan Parry. It's about space equipment, space junk, hundreds of redundant satellites and equipment in space. Would you say that we're now disrespecting the environment of space as we are doing so on our own planet? That's from Jonathan and Rachel.
Yeah, that's a really important question from Jonathan and Rachel. And actually, I think in the early years of space exploration, yes, we were perhaps a bit naive in terms of what we were doing and what we were putting into space. But more recently, we're actually really making huge efforts to clean up space. Every satellite that is launched today has to have a means of either re-entering Earth's atmosphere and burning up, or being able to take it away from planet Earth into safe orbits that aren't going to cause any problems with debris. The International Space Station, of course, has to do debris avoidance maneuvers, a few of them every year, and it's something that we take extremely seriously. So great, I'm very grateful for the fact that we've now acknowledged the fact that space debris is a huge problem, and that everybody on Earth is making huge efforts to try and resolve this now and to clean up space.
I think we've only got 4 minutes left on our call to you, so we're going to rattle through as fast as we can. Emily, another space student here in the studio, your turn for the question.
Hi Tim, I'm Emily. My question for you is, with your experiences on the ISS, what do you think the challenges would be of establishing a moon colony, and do you think one would be necessary in our mission to Mars?
Hi, Emily. Yes, well, a moon colony, that's a great ambition to have. And again, it would be wonderful to see that going forward as another international collaboration, using what we've done here as the International Space Station as really a benchmark for how we can continue to explore the solar system. I think a moon base is a very logical step on the way to Mars. It enables us to investigate many of the challenges we're going to face in terms of radiation exposure, energy production, and yet it's the kind of safer distance, if you like, and the safer environment of the moon. However, the moon in itself is a wonderful place to set up a location for research. There's a huge amount that we've still yet to discover about the moon. It can tell us a lot of things about the origins of our own planet. After all, it was part of our own planet at one time before it was struck. Also, the dark side of the moon, for example, is a great place to have a space observation laboratory or telescope into the rest of the solar system. So the moon is a very exciting place. I hope that we will see that as a next destination in itself, and also as a stepping stone for Mars in the future.
Tim, there's a lot of interest in microgravity, of course, and this is a tweet from Simon Meller. If you hit a golf ball, theoretically, on the ISS, how many yards could you hit it?
Well, that's a good question. Inside the space station, we could probably get it about, maybe 75 meters before it bumped into it, end to end from the space station. But, of course, we're in a fairly confined environment up here. It would be great to do that experiment outside on the spacewalk and see how far we could track it.
I've got a ball there. I can see it floating next to your right shoulder. Why don't you give it a throw towards the camera, see what happens? Will it dip or will it just keep on going?
Everything up here just carries on going until it either bumps into something, or if it's very light, then we do actually have air circulation. And so the airflow throughout the space station will keep things moving, which is always a good thing. If we lose something, we always know where to go. We go to the vents, the air ducts, and that's where we find our lost items.
Tim, just time for one final question for you. Obviously, your first time in space. Is it like a drug? Or are you going to have to go back? I mean, this may be something you want to talk to your wife, Rebecca, about before you announce it live on Sky News, but do you think this is going to be the first of many trips?
It certainly is very addictive. The view from the cupola, taking photographs, is great to be up here. It's a wonderful experience. It's a huge privilege to be able to experience this as well. I'm really happy the European Space Agency has got an excellent track record of flying its astronauts, and after me later this year will be Thomas Pesquet, who will be the last of my class of astronauts to fly. And there are certainly plenty of other opportunities going into the 2020s with further space station research, but also space flights into other areas as well. So it's a very exciting time for human space flight. So I certainly hope that there are a few more flights to come.
very best of luck to you, Tim, and thank you so much for agreeing to talk to us and for answering all of our students' questions here in the studio, the questions from the children up at Leicester Space Station, and the questions from all the Sky News viewers who've been tweeting in and emailing in over the last few days. We've got to let you go now. There's only 15 seconds left on the satellite, but thanks again from all of us here at the Sky Studios.
You're welcome. It's a huge honour to speak to you, and it's been great. Thank you for the wonderful questions, and to everyone in London and at the National Space Centre in Leicester, goodbye.
Station, this is Houston ACR. Thank you. That concludes our event.
Thank you, Sky News London. Station, we are now resuming operational audio communications.